You're welcome back from break. Let's continue from where we stopped. Let's look at example 3. What is the locus of the midpoint of all chords of length 6 cm with a circle of radius 5 cm and center hole? Option A, a circle of radius 4 cm with center hole. B, the perpendicular bisector of these chords. C, a straight line passing through center hole. D, a circle of radius 6 cm and with center hole. The correct answer there is option B. Option B, the perpendicular bisector of the chords. Let me explain. Given a circle like this, don't mind my circle. No, it's my hand. It's not compass. So, center hole, radius 5 cm, chords. Let me give chords to be like this. Chord 6 cm. If there is another chord like this, another chord like this, we don't know the number of chords there, but from the center, if you trace the radius from the center, if you trace the center to the chord, the radius is 5 cm. Trace the center to the chord here, see another chord, trace the center to this chord. See another chord, trace the center to the chord. Even here, trace the center to the chord. You realize something, that the line from the center cuts the chord into 2 equal halves. And what does that mean? It means that that line is a locus of point equidistant from the 2 ends of the chord. So it's a perpendicular bisector of the chord. That is why the option B is the correct answer, the perpendicular bisector of the chords. So that's it. The locus of the midpoint of all chords is the perpendicular bisector of the chords. Let's consider example 4. Yet under the last locus. Example 4. The locus of a point P, which is equidistant from 2 given points S and T, is option A, the angle bisector of PS and ST. Option B, a perpendicular to ST. Option C, the perpendicular bisector of ST. Option D, a line parallel to ST. The correct answer there will be option C, that is the perpendicular bisector of ST. Look at it. Given this line, and we have ST as the 2 points that form the line. If that is the case, the locus of a point P, which is equidistant from the S and T, from the 2 points, S and T, that is, that has equal distance from S and from T, will be here, will be the bisector of the line ST, perpendicular bisector of the line ST, which divides the ST into 2 equal halves. Do you understand? So, and this kind of line is a perpendicular bisector of ST. So, the reason option B is not correct is that a perpendicular line to ST may not necessarily be a bisector of ST. A bisector of ST divides ST into 2 equal halves. So if it is a perpendicular bisector, then it divides it into 2 equal halves and it is perpendicular to it. But if it is not a bisector, it could be a perpendicular to it, not necessarily being a bisector, like a line like this. This is a line. This line may be perpendicular to this, but it is not divided into 2 equal halves. Do you get it? In that case, B will be the correct description, but C is the perfect answer in this case. Let's consider the next example 5. If P and Q are fixed points, and X is a point which moves so that xp is equal to xq. The locus of x is what? A straight line. The perpendicular bisector of PQ is circle. The bisector of angle PXQ. The correct option here is option B, the perpendicular bisector of PQ. Let me explain. If P and Q are fixed points, that is P and Q, they are fixed points. Two fixed points like this will form straight line. Anyhow. And X is a point which moves so that XP is equal to SQ. That is, it is a line like this. And that line is called X here, such that XP is equal to XQ. What does that mean? That means the distance between XP is the distance between XQ. That means that line is the line that divides them into two equal halves, such that this end is equal to the other end here. And this line is called a perpendicular bisector of line PQ. A perpendicular bisector of line PQ. A bisector divides something into two equal halves. So the correct option is option D, the perpendicular bisector of PQ. Let's consider example 6, which is going to be the last example on loci, especially locus 6, which is the last of the loci. Example 6. The locus of all points at a distance 8 centimeters from a point N passes through points T and S. If S is equidistant from T and N, find the area of triangle STN. Well, let's take it like this. Let me stoop down. Let's say this is our circle. Don't mind the way my circle is. I don't have compass here. With the center. The locus of all points at a distance 8 centimeters from a point N. That is a circle. You must have known that. The locus of point equidistant from a fixed point is a circle. So this is the N. That fixed point is N. This radius, 8 centimeters, is the distance we are talking about. So the locus of all points, you can see, it could be like this, like this, like this, like this. That's why we call it all points, all around like that. It's going to be 8 centimeters always. Now, that is it. Let's read on. Passing through points T and S. Let's say we have T here. We have S here. You know, it passes through points T and S. The locus we are talking about there is the circle. And that circle passes through T, passes through S. You can see it passes through T, passes through S. Let's read on. If S is equidistant from T and N, S is equidistant from T and N. This is Tn. Tn is a radius as well, 8 centimeters, as you can see. And S is equidistant from T and N, meaning that this S cuts through the Tn at the center. Let me take it through the center. Then this is the S. So in this case, S is equidistant from T and N. Meaning that the locus of this S, the line that comes from this S, cuts Tn into two equal halves. Find the area of triangle STN. So we can see that there is a triangle here. There is a triangle here, ST. Let me trace it. STN. There is triangle STN. In that, the line that comes from S here is the perpendicular bisector of Tn, cutting it into two equal halves, meaning that this place will be 4 centimeters. This also will be what? 4 centimeters. And we have to find the area of triangle STN. That triangle, the area will be half base times height, which is half times base. Your base here is 8 centimeters. Height is unknown. Look at it. The height is here, which is unknown. How do we now discover the value of our height? So let's stop that there. Don't forget, NS also is 8 centimeters because it's a radius as well. 8 centimeters. So, using Pythagoras rule to obtain h, I come here, h square will be equal to 8 square minus 4 square. I hope that is not ambiguous to you at your level. Using Pythagoras rule to find this, to find the height h. Pythagoras rule, so that gives this, which is 64 minus 16 h square. H now will be square root of 48. 64 minus 16 gives 48. So that will be square root of 16 times square root of 3. And the answer to that, h is 4 root 3 centimeters. Square root of 16 is 4 times root 3. That is 4 root 3 centimeters. Now bring that value of height into these workings. You now have 4 root 3 centimeters. Don't let me put the centimeter there to allow the space here. We will put it at the end. 2 in 8, we have 4 centimeters times 4 root 3 centimeters. 4 centimeters times 4 root 3 centimeters gives 16 root 3 centimeter square. And that is the answer. That tallies with option B. Is a more technical question that is, but you can master it. And that is where we are drawing the curtain on loci. After this, we move straight to calculus.